And the properties, there it is. And the properties are the definition of a logarithm, the change-based formula, which we'll go over that later, the property of the product rule, the quotient rule, and the power rule. Those are the properties that we will be using when we're solving for x and your exponential laws. Your exponential laws are also included in there. So right now we've covered the definition of a logarithm. Now we're going to cover these three right here. Okay. So with that being said, I'm going to give y'all one more chance to write these down. There they are right there. The product rule, the quotient rule, and the power rule. And we're going to do an example just as soon as I get rid of this. So those of you that didn't make your index cards and didn't print those things out that I told you to print out, there is the first three rules. So you might want to take a picture or, write them down right quick. Give y'all another minute or two. Okay, so let's go ahead and look at one of the examples. Now, let me go ahead and say right now that with these properties, you can rewrite / simplify / expand. That's usually when you don't have an equal sign. Okay, and I think in 6.6 or wherever, the last section, one of the last couple of sections, we're not going to rewrite, we're going to solve. And that's when we solve in equations, and you will have an equal sign. So again, I just want to reiterate that these properties are used not only to rewrite, but they're also used to solve. Okay. So let's take a look at our first example. At least I think there's going to be an example. And there is the example. There's two examples. Now, they do not have equal signs, so therefore, they're not equations, they are expressions. So we're going to rewrite. So log of 8x, and then log base 9 of 15 over 7. So there's our examples. And this one is multiplication. So therefore, we're going to use the product rule on this one. And the product rule says that if I have something that I'm multiplying, then I basically expand it by saying log base 8 plus log of 8 plus the log of x. It's just like your exponential laws. And this is going to be log base 9 of 15 minus log base 9 of 7. Now I'm going to go ahead and interject the change base formula right here. I interjected it last week a little bit, just one problem, but I want to go ahead and interject it here. And the change base formula basically says that if you have log base, I'm going to put a B here, of a number, and we'll just say M, and B is not equal to 10 or E. Okay, so if you don't have log base 10, which is log, or if you don't have the natural log, okay, then you have to use the change base formula. And it says that if you have a base that's not 10 or E, then you will change it to the log base 10 or E of M over the log of B. And that will be the change base formula. And you will see that, and some of you already have that in the handouts that I've already given you. So if I wanted to change this with the change base formula, this is your answer. But in the future sections, this would be log of 15, excuse me, I got corona, log of 9 minus log of 7 over log of 9. So this is for the future, this change base formula. Okay, so that's how you use, and you can go both ways. If you're given a problem like this, you can change it into that. And if you're given a problem like this, you can change it into that. Now, again, I don't know how many of you have actually used logarithms and logarithmic properties. I don't know how many of you have seen them. And I'm going with the assumption that there are a few out there that haven't seen them. I realize that some of you actually created the logarithm properties, but there are some that have not seen them before. Okay? So let's look back and see what the answers are. And there are the two answers. Now they'll give us the properties. There's several more, so let's do this one. I'll write them down and then we'll do them. Log base 5 of the square root A. Log 0.01 or 0.1 and 2 log base 2 of 3. If y'all are doing it to write them down. Okay. Now, one of the things that I teach you in calculus is radicals and calculus don't mix. So the first thing you would do here is you would rewrite this one as a, hold on, excuse me. I don't know why that came up. Oh, come on. Sorry about this. I don't know why this came up. Okay, now. Now, I would rewrite this as log base 5 of 8 to the 1/2 power. And then I would change that by the power rule. This would come out front. And then that would be 1/2 times the log base 5 of 8. And I'm going to go ahead and interject the change base formula in here. And I'll do it in pink because that means that I'm doing it extra. And therefore, when we get to the change base formula, it won't be, it won't blindside you. So that's going to be log of 8 over the log of 5. And I'm going to multiply that by 1/2. Okay, now that's in pink, so that's kind of extra. This is the answer that you're looking for. Okay, that's the power rule. Now the next one, there really is nothing you can do except for one of the properties that we've gone over. Well, you could use the, yeah, you could do that. I didn't even think about that. So let's go with changing this to a fraction. And that would be log of 1 over 10, which is equal to log of 10 to the -1, which is equal to -1 log of 10. Now, log base 10 of 10 is equal to 1, so the answer is going to be -1. But I think what they're really trying to show you is manipulation of the radical and manipulation of a decimal. In other words, should you be able to rewrite it? Yes. And this is the property where the base equals the base here. Does somebody have a question? Those two are the same, and if they're equal, then the answer is 3. They're equal, so the answer is 3. And this answer could be -1. I don't know if they took it that far because these two bases, I mean, these two numbers are the same also. So I don't know if they're carrying it that far. We'll look and see here in just a second. Yep. And 3. So there's 5 test questions right there. Now, if you want to do well on this test, then you make sure you can rewrite using the product rule, the quotient rule, and the power rule, because the other 30 or 40% of your test is going to come from the equations. And if you suck at these properties, you're going to suck at solving equations. Okay? I don't know if y'all wanted me to sugarcoat that, but I'm sorry, I don't sugarcoat. All right, try those. I'm going to let y'all do those two, and then we'll do them together. So I'll give you a couple of minutes. So I'm going to put the timer on. Well, you've already been working on it 30 seconds. So I'll give you about another minute and a half. log base A of x over yz and log base A of the third root of m to the second power. Okay. So this one, by using the product or the quotient rule, is log base A of x minus log base A of yz. And now we can use the product rule and do log base A of x minus, and if you want to put it in parentheses, you can, log base A of y plus log base A of z using the product rule. And then you distribute that negative, and or you could leave it like this, either way. I don't know. Let's look and see how they did it. If they want it, yeah, they distributed the negative. So you can distribute that negative and you will get the answer log base A of x minus log base A of y minus log base A of z. Here, the first thing I'm going to do is I'm going to rewrite it. Log base A of m to the 2/3 power. And then I'm going to bring that out. And that's going to be 2/3 log base A of m. Now, there's really not anything you can do there. I'm going to do the change base formula, and I'm going to do that in pink because you don't have to. But I'm just trying to help y'all out. Y'all realize I'm trying to help y'all out. I'm not trying to make y'all fail. Just want y'all to know that. Okay, log of m over log of a. That would be using the change base formula. Okay, so let's look and see what they got. Log of x minus log of y minus log of z, and 2/3 log of a over m. Log of a m. All right, do that one. Of course, many of you will do what on this one? What will you do on this one?
Quit.
Quit. Good job. Yes.
Spontaneously
quit.
convulse.
Huh?
Spontaneously convulse.
Yeah, spontaneously convulse. That would be good. Quit. Spontaneously convulse. Spontaneously combust. I like to quit though. That's good. When the tough get going, what do? Blame the Russians. It's all the Russians' fault. Give y'all another minute or two. And make sure Miss Ramey, or Ramey, I can't tell with the first name, but I'll just say Ramey. You blame the Russians and quit. I had a student advisee ask me, I don't need to take Math 103, English 103, because I've already taken it. I said, well, we don't have it here. And they said, what do you mean have it here? I said, well, we have to have a copy. If you've taken Math 10 or English 101 and 102, which is Math English 103, you have to send it here. Well, I said, where did you take it? And they told me college, blah, blah, blah. And I said, well, you need to send your transcripts here so that you don't have to take Math English 103. Oh. Well, I just got a text from that student. Okay, they sent it. It's still making me take 103. I said, when did they send it? I said, he basically said, yesterday they said they would send it. I said, well, it's got to get here. I said, it's got to go through student records and it's got to be approved. Oh. Yeah, there's some things that still run on snail mail. For those of you that don't know, you have to if you take a course, you have to send your transcript to the other college so they know. Oh, Lord. Log base b of the nth root, excuse me, of x to the third, y to the fifth, over z to the m. So here is our problem. Yeah, Mr. Lynch, that's very true. Some high schools or colleges are very stringent on when they send transcripts. So I'm glad you got it sent. Yeah, there's especially with dual enrollment. Dual enrollment has to be sent because we don't know, that you took those courses. You said you took them, but we don't know that unless we have a piece of paper from the college that says that. I know. Man, and you got to realize some institutions are behind technology-wise, and they're not only behind technology-wise, but they're behind technology as far as attitude. They still believe that you have to do everything by snail mail. And I disagree with that because I believe you have to be moderation. Everything's in moderation. I believe that you should have, the ability to send things and request things via email or send through email, as long as it's got the letterhead on it and email that says you verify it, then I don't see a problem with it. But again, you have people that will manipulate the system, and that's why, we have problems. Okay, so here we go. I'm going to change this into log base b of x to the third, y to the fifth, over z to the m raised to the 1 over n power. And I can now, 1 over n. And I can now distribute that 1 over n. I can distribute that with each of these using my power rule of exponents. Or I can bring this out to the front using my power rule of logarithms. It doesn't matter which one you use, as long as you use one of them. Okay? So I don't know. I'm going to use the logarithm. Since we're dealing with logarithms, I'm going to use the exponential law of logarithms by power rule. I'm going to put this out front. Or, like I said, you could say 3 over n, 5 over n, and m over n. You could do that if you wanted to. But I'm going to bring that out front, and it's going to be 1 over n, and that pen is dead. It goes to the trash. Hold on just a minute. My son is calling for some reason. Hold on just a second. He made an A on his test. He was excited. I told him he sucked. All right, 1 over n, and that's going to be log base b of x to the third, y to the fifth, over z to the m. Okay? And now I'm going to use the product and quotient rule right here. And I'm going to bring my 1 over n down. Log base b of x to the third plus log base b of y to the fifth minus log base b of z to the m. Now I can use the power rule and bring this out front. And I get 1 over n, 3 log base b of x plus 5 log base b of y minus m log base b of z. And now you can distribute that 1 over n and get 3 over n log base b of x plus 5 over n log base b of y minus m over n log base b of z. Now, the good thing about exponential rules and logarithmic rules is that you can do it several different ways and still get what? That means I want y'all to interact with me. Still get the correct answer. That's right, class. Thank you. Y'all decide not to talk to me anymore? That's fine. That's fine. I understand. Y'all suck. All right, so let's check the answer and see what we get. Three over n log base b of x, 5 over n log base b of y, m over n log base b of z. And I can tell you right now, this is a test question. So you better get used to this one, because you're going to see this again, and you will see this on standardized test also. And let me go ahead and tell you right now, if you want to fail this test, then the best thing to do is to do not work on 6-3 homework until the last minute. And I will assure you, you'll fail the test. So 6.3 is detrimental to making a good grade on the test. Of course, if you don't cheat, which I'm not going to be able to stop anybody from cheating. It's like trying to stop people from stealing. Okay? Use the properties of logarithms to write each expression as a single logarithm. So now we're not expanding, we're going to condense. or simplify. So write these two down. Log base 3 of x plus 2 plus log base 3 of x minus log base 3 of 2. And the second one is 2 log base a of m minus 3 log base a of n. Now, the good thing about the first one is that it's ready to go because you've got log base 3, log base 3, and log base 3, and there's nothing in front of the logs. If you've got the same base and you've got nothing in front of the logs, then you're ready. So this is going to be product rule and quotient rule. So log base b, log base 3 of x, this parentheses times that. So x times x plus 2 over 2. And that can be simplified as log base 3 of x squared plus 2x over 2. Now I'm going to circle both of these because depending on the book or the test or the person, sometimes they like this, sometimes they like this. Now I had a professor at Clemson, Dr. Ruckel, and he was my advanced Calc 1, 2, and 3 teacher. Played Tetris all the time. And he was about 107. He'd been teaching at Clemson for about 200 years. And I wouldn't be surprised if he's still not there. Anyway, he was about 6'3", weighed about 300 pounds. I mean, very big guy. And he would say, how do you tell if something is simplified? The number of times your pencil hits the paper. And we would look at him like he's crazy. Here is he, a calculus phenomenon teacher, teaching at Clemson University, and he tells us that simplification is how many times your pencil hits the paper. And he was right. Every time your pencil hits the paper, determines how something is simplified. So let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So when I rewrote that, that was 15 times. Now let's rewrite this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I have checked him since 1990, I guess 1993, 1994, because I graduated right after I had him. I have been checking problems since 1994 with his theory, and he is 100% correct. The number of times your pencil hits the paper. So let's do this one. So if you're in mathematics at Clemson, look up Dr. Ruckel. Now I know my advisor, I told you he was dead because I got a plaque of him beside his office. He was Dr. Harden. He was the one that grunted all the time. You know how to do that. That means you know how to do this. So this one, I've got the same basis, but what's the problem? Somebody tell me what the problem is. That means I want you to talk.
There's numbers in front of the logs.
There's something in front of the log. So I've got to move it using the power rule. So that's going to be log base A of m to the second power minus log base A of n to the third power. Now I have the same basis and nothing in front. So I'm going to use the quotient rule. And I'm going to say log base A of m squared divided by n to the third. And there's your two answers. Now see, they didn't carry those further. But I think I've shown you that the second answer is more simplified. All right, try this one. We got 4 minutes, so that gives y'all 2 minutes, and it gives me 2 minutes to do it. So, or I'm sorry, 1.5 minutes. Gives me 1.5 minutes and you 1.5 minutes. 1/2 log base b of m plus 3/2 log base b of 2n minus log base b of m squared n. All right, I'm going to give y'all till 9:58 or a little bit after that. You mean, Mr. Lynch, they cut off 2006 when you could request transcripts digitally? So they went from digital to snail mail? Is that what you're saying? Okay. Oh, okay. Okay. So now you can request by email. I guess that's what you're trying. Yeah, I see what you're saying. Yeah. Yeah, I think, and see, that's where your moderation. Yeah. To me, that's. I think moderation plays a key. Okay, let me go ahead and do this one. First of all, I've got the same basis. I've got the same basis, so I need, here's my base, here's my base, and there's my base. But that 1/2 and that 3/2, I got to fix that. So log base b of m to the 1/2 plus log base b of 2n to the 3/2 minus log base b of m squared n. And now I'm going to use the product rule here. So that'd be log base b of m to the 1/2 times 2n to the 3/2 divided by m squared n. Now, this can get a whole lot messy. I don't know if they want you to be messy with this or not, because this would be the square root of m, and you could actually combine these two. And this would be 2 to the 3 halves, n to the 3 halves, and you could combine the 3 halves. So what I'm going to do is I'm going to rewrite this, and we're going to stop there. Log base b of m to the 1/2 over m to the 2nd times n to the 3 halves over n to the 1 times 2 to the 3 halves over 1. And what I did is I broke this up. That 3 halves goes with that one and that one. And I wrote them over the common bases. Because if they want you to go further, they may want this as the answer, which I don't think they do. I think they want you to do this. So we're going to stop right there, and you can work on this. 1/2 minus 2 is 1/2 minus 2 is negative 3 halves. 3 halves minus 2 halves is 1/2. So this is going to be m to the negative 3 halves, n to the 1/2, I think, and times 2 to the 3 halves. And you can keep on because you got to make that into a fraction with a positive exponent. And they may want you to put radicals in it. Let's see what they did here. Yeah, see, they're taking it on further. There's the 2 to the 3 halves, n to the 1/2, and then the 3 halves come down. So they're wanting you to, we're right now right there. That's where we are right now. Okay, so work on that for homework. Now you should be able to finish up a lot of 6.3. Let me shut down the recording and just check and see